Hello, this is Keith Capillero from K-Dawg Weather, and today I'm going to be talking about exploring waterspouts, nature's spectacular phenomena. Let's get started. The agenda overview: understanding waterspouts, formation and development, geographical distribution and occurrences, impact, safety, and observation. Understanding waterspouts. Definition and characteristics of waterspouts. Waterspouts are rotating columns of wind, cloud bases to water surfaces appearing as funnel-shaped clouds. Classified as weak tornadoes, waterspouts differ by forming over water rather than land, impacting their behavioral environment. Waterspouts range from 50 to 1,000 meters in diameter, lasting several minutes up to a half an hour with strong winds and water spray. Type: fair weather versus tornadic waterspouts. Fair weather waterspouts form in calm conditions under cumulus clouds, light wind shear, and are less destructive. Tornadic waterspouts originate from severe thunderstorms with strong rotation, causing powerful and damaging effects. Fair weather waterspouts account for approximately 80% of waterspouts occurrences worldwide, making them the most common type. Next is the key differences from land tornadoes. Waterspouts are smaller and shorter lived compared to land tornadoes, affecting their overall impact. Waterspouts produce lower wind speeds ranging from 40 to 72 miles per hour, unlike land tornadoes, which can exceed to 200 miles per hour. Waterspouts develop under less intense wind shear and often form without supercell thunderstorms unlike land tornadoes. Due to their aquatic origin, waterspouts causes minimal damage compared to destructive land tornadoes. Formation and development. Meteorological conditions required. Waterspouts required ocean and lake surfaces warmer than 26 degrees Celsius to provide energy for vortex development. High humidity and light surface winds combined with moderate wind shear aloft are essential for spout formation. Cumuliform clouds and unstable atmosphere promote vertical air movement needed to create the waterspout vortex. Slight variation in water temperature greatly affect convective activity, influence waterspout formation. Stages of waterspout formation. Waterspout formation starts with a dark spot on the water surface indicating early vortex development. Spiral patterns emerge on water reflecting horizontal vorticity and a strengthening vortex motion. A visible condensation funnel extends from the cloud base to the water surface, making the waterspout signature feature. The mature waterspout shows strong vortex circulation with distinct spray rings around its base. Roles of temperature and humidity. Warm water and cooler air creates instability needed for vertical air motion and spout formation. High humidity provides moisture for condensation, forming the visible funnel cloud of waterspouts. Water temperatures above 26 degrees Celsius and dew points over 20 degrees Celsius increase the likelihood of waterspout significantly. Variation in temperature and humidity influences the intensity and longevity of waterspouts. Geographical distribution and occurrences. Common locations around the world. Tropical and subtropical region. Waterspouts are commonly formed in tropical and subtropical coastal regions where warm waters and high humidity prevails. Florida, especially in the Florida Keys, experience over 400 waterspouts annually, making it a hotspot globally. Waterspouts also frequently occur over the Great Lakes, Mediterranean Sea, and Gulf of Mexico coastal zones. Seasonal pattern and frequencies. Waterspouts mostly form in warm months, peaking in late summer and early autumn with highest water temperature. Seasonal frequency of waterspouts is linked to sea surface temperatures and atmospheric patterns like trade winds and frontal boundaries. The Mediterranean Sea's peak waterspouts occurrences in late summer with up to 30 spouts annually in prime season. Some of the notable historical waterspout events. A 2010 waterspout in the Florida Keys produces 70-mile-per-hour winds, causing minor damage to maritime vessels. The 2015 Lake Michigan waterspout was extensively documented by photographers drawing scientific interest. Waterspouts impact marine traffic in coastal communities, underscoring the importance effective of monitoring systems. Impact, safety, and observation. Potential hazards and risks. Waterspouts can damage small boats and coastal properties when they move ashore, posing risks to maritime activities and residents. Waterspouts present hazards to swimmers and low-flying aircraft due to strong winds and water spray, reducing visibility and causing disturbances. Although injuries from waterspouts are rare, awareness and caution are essential to avoid direct encounters and ensure safety. Safety guidelines for all boaters in coastal areas. Boaters should keep several miles away from observed waterspouts to ensure safety. Constant monitoring of weather updates help boaters anticipate hazardous conditions early. Having clear evacuation plans in coastal areas is essential for quick response during emergencies. Meteorological agencies issue warnings when spout conditions are favorable, reducing accident risks. Technique for observing and forecasting weather. Radar signature and satellite imagery enable accurate prediction of waterspout formation. Mariner and coastal residents rely on visual observations supported by real-time ocean buoys and data, and also a lot of skywarn spotters. Doppler radar technology improves early detection, allowing warnings up to 30 minutes in advance. The conclusion: embracing the fascinating nature of waterspouts. Waterspouts have unique features and formation process that distinguishes them from other weather phenomena. Waterspouts occur worldwide under specific weather conditions, highlighting their widespread natural presence. Understanding safety measures and forecasting techniques help reduce risk and enhance human awareness around waterspouts. Thank you very much for this PowerPoint presentation. This is Keith Capillero from K-Dawg Weather. Please like and subscribe to this channel. Thank you.